Graph the following polynomial. F of x equals 3x minus 1 times x plus 2 quantity squared. So let's first identify the zeros of this polynomial. If I take each of these factors and set them to 0 and solve, that would tell me what the zeros are. So 3x minus 1, if I set that to 0, would result in 1/3. And you can check that on your own if you're unsure about that. If I set x plus 2 equal to 0, then I get another 0 at -2. But because of this square right here, this is a 0 of multiplicity 2. So something happens a little bit different at that point. So we have a 0 at 1/3, so I'll just estimate it about right there, and -2. So at -2, because it's multiplicity 2, wherever the graph is, it's going to come down and touch the graph at this point, touch the axis at this point, and then bounce away. Or if it's negative already, then it would do this. But regardless, it touches the axis and bounces away because it's multiplicity 2. This one would cross right through the axis. So let's see about the end behavior. So the number of zeros that we have indicate the degree of the polynomial. So I have two distinct zeros, but because one of them is multiplicity 2, that gives me a total of 3 zeros overall, which is an odd number. The leading term coefficient here, it's not written, but it's sort of understood to be a positive one. And if it's positive 1, then the end behavior is greater than 0. So we would start in the negative direction and end in the positive. This is going to look just like the x cubed graph. So I'm in the negative direction to begin with. I'm going to come up, touch this 0, and then bounce back away. And then my graph turns and goes back through this particular point right here. And that's a decent sketch of this particular polynomial. And it isn't going to be perfect. If we were to use the calculator to graph it, so if I took 3x minus 1 times x plus 2 squared, and I graph this in the standard viewing window, and this is what I get. And that's actually fairly similar to what I have, although this particular valley here went a little bit lower than what I drew. But that's okay. The heights of these peaks and the how far down these valleys go, that's something that we learn how to deal with in calculus. So for now, as long as your end behavior, multiplicity, and location of zeros match up, you're all set.